Hi guys, how are you? Alexander, Thomas. Alexander,
We-
please
I'm very well.
introduce yourself.
Hi, colleagues. Okay, hi, colleagues. My name is Alexander. I'm a front-end engineer, open source contributor, and Ember.js lover. And today I'm glad to introduce you Thomas Steiner. Glad to see you, Thomas.
Hi, glad to
Could
see
you
you too.
say a few words about you?
Добрый день, меня зовут Томас. Говорите по-русски чуть-чуть, and that's all my Russian. I can say как дела. So yeah, I'm really glad to be here. Thanks for the kind invite, and yeah, let's kick it off.
Okay,
Okay.
but first of all, I have a few warm-up questions for you. And tell us your story. How did you join it into front-end?
I'm technically not a front-end engineer. I'm a developer advocate, which means I work on the web platform per se, which means anything from new browser APIs, but also any kind of yeah platform features that you might want on the web. So on my team, we work on getting everyone to write applications on the web so that they don't have to write Android applications or iOS applications if the same thing can be done on the web. And if it can't be done on the web, my team works on making it happen in the future. So that's essentially what I work. How I got into there, I'm a computer scientist by education. So did a master's degree in computer science, did a PhD in computer science, and then joined Google, and the rest is history. Here I am.
Okay, thank you so much. And so, you exploring a web platform as a place for some business needs. And could you tell me, from point of view in 2020, how many things can be done in a web in percentage, average percentage?
Oh, a lot. The thing is, when it comes to browsers, there's of course not just one browser, and that's a good thing. There's different browsers that have different capabilities on different platforms. So in general, I would say a lot of things can be done already. I'm, to be honest, not sure about the percentage, but a lot of things. The thing is, not always. So sometimes you might need a feature that is supported, but maybe only on, let's say, desktop, but not on mobile. So one concrete example is on my team, we have enabled file system access so that now you can access the file system using web APIs. But this doesn't work on mobile yet. And it also doesn't work on, let's say, iOS or Firefox yet. But if your niche is using desktop browsers on Windows, Mac, Linux, Chrome OS, then you're in a good position. But yeah, this is the thing. Right now, the situation is, yeah, sometimes things work on some platforms, sometimes they don't on others. But a lot of things can be done already. If you look at most applications that are on app stores these days, a lot of them could be also implemented on the web.
Okay, and I want to ask top five from your side. Could you mention top five your favorite browser APIs from 2020 or from past years?
So file system definitely is number one. It unlocks so many new use cases. Second, I would say is probably the new clipboard capabilities that now you can access also binary files on the clipboard, not just text, and with a reasonable API, not some archaic old school thing, but like an API that was made for doing what you want to do. Let's see. Local fonts is an exciting API for getting access to local fonts, especially when it comes to design tools. What else? We have some new, just small additions that can work, like for example, a keyword lock API, which is very useful when you have devices that, or actually operating systems that get streamed over the internet, so you can work on your server that is in your office, but actually be at home. And at home, you may have a Mac computer, but your server might be a Linux machine, but still you can stream your Linux server to your Mac browser. And then, of course, some keyboard shortcuts like, I don't know, Control Z or Control whatnot would be typically consumed by the Mac machine, but if you have a keyboard lock activated, you can make them stay within the browser tab. So these kind of small things that just improve your experience. And I think I mentioned 4 now. Let's see. Window placement is another very exciting API, especially when nowadays you have, maybe at home, smaller screens grouped together, whereas in the office you may have one massive screen. Most people at home try to somehow rearrange their desktop environment, but not everyone has the hardware. So long story short, window placement is another API that allows you to get access about your screen configuration in the web browser. So I think that's 5.
Sounds very impressive. Thank you so much. And so let's go to your speech. And could you briefly answer, how did you get idea of this speech?
I was essentially thinking, there's a lot of APIs out there. There's a lot of things to learn, but not always everyone has the time to dive into everything, and not everyone has the time to stay up to date on all the things. So my idea here is for this talk, I present a couple of things, and after the presentation, if you're interested in something and you realize, I totally want to learn more about this particular thing that Tom mentioned, that now you know where to go, where to reach for support and reach for just more information. So my idea is essentially present you way too many things, but then you can cherry pick the ones that you actually want to learn about.
Oh, it's amazing. I can't wait. So Thomas, let's proceed. Are you ready?
I'm ready, and I hope everyone else is ready.
Yeah, let's go.
Let's go. Thank you.
Cool. So here we go. The wonderful world of new web APIs. Leave no one behind. This is a hashtag that you may have seen online or offline recently in the last couple of months and weeks that have not been easy for a lot of people, including myself, but I'm more on the lucky side. There have been people who have been hit way harder. This image that you can see here is from a club in Hamburg, my current hometown. And of course, all clubs are closed. So clubs had a hard life before. They always were fighting for money, and now they have to be closed. So for this club owner, life is a lot harder than it is for me. But essentially, yeah, this is the message. Leave no one behind. And a lot of people have been sharing this hashtag on Twitter, on walls, as you can see here. So this is what I want to talk about. My name is Thomas Steiner. I work for Google in Hamburg, Germany. And today I want to talk about leaving no one behind when you develop with web APIs. And there's a ton, which is why I called this talk The Wonderful World of New Web APIs. You can find me on the internet, on Twitter, on GitHub in general, under the name Tomayak. So if there's anything you want to ask, just reach out on any of the channels. You can find me easily on the web. So before I start talking about today, I want to talk about the past. This is 2003. And 2003 was the year where Stephen Champion and Nick Fink introduced the concept of progressive enhancement. 2003, that's, wow, 17 years ago. Why does 2003 matter today? The thing is, progressive enhancement still matters today. And one of the rationales for using progressive enhancement is to allow for the adoption of new technologies and strategies without leaving no browser and no operating system behind. So here you have the connection to today. Leave no one behind is something that drove the creators of the concept of progressive enhancement even in 2003. And the concepts may have been different, but today the same core concept still matters. So what does this mean in practice? Let's have a look at a small, really cool application that you may remember from the days of Windows 95, Paint. Someone has actually re-implemented Paint in JavaScript. If you scan this QR code, you can go to the demo, and you can just run Paint as it was in Windows 95, but in a browser today. Scan the QR code to try it. And Paint has this very cool spray can tool where you can just spray something, and it looks, for the time, really reasonably good. So remember, this is 1995, where Paint came out with Windows 95. So let me try to recreate the graffiti that I saw, or that I showed you on the first photo, leave no one behind. You can see I'm not a great graffiti artist, so maybe I just should use the text tool and write leave no one behind using the text tool. So this is what I do. You have this small text box, and it looks okay, but maybe a little boring. So my idea is, why not choose a different font? And if I select the font tool that you can see on the screen, it has like 24 fonts in total, which is not many. 24 fonts is a couple, but it's definitely not all of the fonts that I have on my computer. But at least I can select Comic Sans, so I can now render the iconic Comic Sans font and write leave no one behind in Comic Sans. But actually, if I look in Font Book on my computer, I can see that I have 310 fonts, so a lot more. For example, I have Wingdings, the good old Wingdings, also from Windows, that made it somehow onto the Mac platform. But 310 is not the 24 fonts that I saw before. So why is that? One of the fonts that I have on my computer is a font called Google Sans. Google Sans is a font that, as the name suggests, is a Google corporate font that is only installed on Google employees' laptops. It's not a web font. It's really a local font that only you can have if you are employed by Google, the company. So it's not a web font. It's a true local font that you install as a file on your computer. It actually just ships with the operating system image that we have at Google. So it's one of the fonts that I might want to use on the web as well. But yeah, the browser exposes a couple of these fonts, but not all of them. What the browser supports and exposes is a set of the so-called web-safe fonts. These are essentially the fonts that you can safely assume are present on every computer on this planet, no matter the operating system. So Helvetica, some sort of Arial, will be present on Linux, on Mac, on Chrome OS, on Windows. But then a corporate font like Google Sans or something very specific like Wingdings might not be present on all computers. So this is why they have the set of the so-called web-safe fonts. And actually, that's a very well-known concept. I've screenshotted here the page from MDN, Mozilla Developer Network, with the documentation of this. So this is there. But the good news is there's work happening on actually exposing all the 310 fonts that I personally have installed on my computer with something called the Local Font Access API. So that eventually, if this API lands in a browser, I could then choose Google Sans, the font, and write leave no one behind in Google Font. But before I dive into the Local Font Access API, I want to shine some light onto where this API actually comes from. Like, how did it even get into existence? If you look at the specification, you can see that it was published by the Web Platform Incubator Community Group. This is written in the spec. I hope you can read it. It's maybe a little small, but it's a screenshot that you can just follow and search for it on the search engine of your choice, and you will find the Local Font Access API spec, and you can read it there if you can't read the screenshot. And it's a link. So when I click through to this link, I land on a page from the World Wide Web Consortium, W3C for short, where you can read the group's homepage. And it looks like this. Here we go. It's a landing page of the Web Incubator Community Group. And at the bottom of this page, there's a link to the group's charter. A charter in the speech or in the language of the W3C is essentially just a list of things that a particular group is tasked to do. So when I click through to the charter link, this is the page that I land on. And yeah, you can see it's a W3C document that contains the group's charter. And if you scroll down a bit, you can read the following. The Web Incubator Community Group, WICG, provides a lightweight venue for proposing and discussing new web platform features. So here we go. The local font access API definitely is a new web platform feature that some people on my team want to land in the browser. So this is the new web platform feature that is in the concrete case the local font access API. Reading a little bit further down in the charter, it says that each proposal will be discussed in its own repository within the group's GitHub account. All right, so there's something GitHub. So let's see what we can find. If you go back to the group's homepage, we can find a long list of all the things that are discussed and being worked on in the context of the WICG, the Web Incubator Community Group. And it's a long list of GitHub repositories where some work is happening. Somewhere down on the left, you can see the local font access API. And if we go back again to the charter, we can read the following. As proposals gain support and become more stable and mature, they will be considered for migration to a W3C working group where they can be put on the recommendation track. Recommendation track. What's this now? So there's a lot of W3C lingo that I want to shine some light on. And the W3C being the W3C, there's always a document that explains stuff in full detail. So this is the W3C process document. And in this process document, I can learn about the processes, as the name suggests, and learn what recommendation track actually means. And let's see. Down there in this document, we can see this diagram. And it's a flow chart where essentially you can see at the right end, there is rec. And rec stands for recommendation. So this is the track for something to become a true web standard. There's a couple of bubbles on this chart. WD means working draft. CR means candidate recommendation. CRD means candidate recommendation draft. We have PR for proposed recommendation. And then finally, we have rec for recommendation. So this is the process for something to become a W3C web standard. And this is the final objective. If you want to become a web standard, you need to end up here at the end of the chart. If you look at where the WICG, the Web Incubator Community Group, would fit in this diagram, it would be at the very beginning. So way before working draft. And this is the connection. For WICG work to become onto or to move onto the recommendations track, this is the path that you need to take. So in the WICG, in the Web Incubator Community Group, are different companies. Some of them are Intel, Microsoft, and Google, among a lot of others and a lot of individual people who also just may join the WICG. But what is special now about these three companies, Intel, Microsoft, and Google? The thing is, these three companies have come together to join forces in something called Project Fugu. So we joined all together and worked on a project to move the web forward. The code name is Project Fugu. The more official name is the Capabilities Project. So we work on making the web a more capable place. And this is finally where the connection comes in from enabling my 310 locally installed fonts to then be maybe one time in the future to be exposed in a font picker like in the Paint application, so that instead of just 24 fonts, including Comic Sans, I could maybe then in the end choose something like Wingdings or choose something like Google Sans on my browser. So that's a connection where this API comes from and where this API hopefully is going to. Unofficial draft. So this is really very early work where people work on making this happen. But actually, this is something that you can play with today. And it's feature detection. What you can see here, why feature detection? Because we don't want to leave anyone behind. Leave no one behind. We want to use progressive enhancement to use this API when it is available, but when it's not available, we don't want to lock out people. We don't want to leave them behind. We want to still enable them to use the application. So this is what I've explained in the beginning, where this API comes from. Now let's actually have a look how we can use this API, what we can do with this API in practice. So as I said, we start with feature navigator object, and if so, we can continue to use the API. Again, leave no one behind. This is what we want. Progressive enhancement should guide the process when we write new applications. So here we go. When we ask for permission to use this API, it may be looking weird in the beginning, but the thing is, this is a very powerful API. Remember what I told you in the beginning. If you know that someone has a font called Google Sans installed on their local machine, you can be pretty sure that this person is working for Google. This is revealing a lot of information for me. So not every website on this planet should be just able to access my list of fonts, which is why we gated this capability behind a permission prompt that allows me to say, yes, I'm using maybe a design application, and yes, in this particular case, I'm fine with this website knowing my local fonts, but I don't want any random any random website to know my locally list of installed fonts. So you use the permission API, navigator permissions.request, and you ask for a local font's name. And if the status is anything else than granted, you throw an error. So this is because the person maybe has canceled the request, or maybe the person has canceled the prompt, or just said blank, no, I don't want to share my fonts with this website. If the status is granted, we can continue. If the status is granted, we can then get access to the fonts by using navigator.fonts.query and access the locally installed fonts like that. This gives us something that we can iterate over, an iteratable, and what we get from it is metadata. So we can ask for await const metadata of fonts. And this will give us the metadata PostScript name, the metadata full name, and the metadata family. And of course, always something can happen. So for whatever reason, something could just go wrong, which is why we wrap the entire thing in a try-catch block. There's a lot of information in fonts that is available as well. Something called font tables that holds a lot of low-level information, like the ligatures of the font, some of the layouting, like how the browser should deal with displaying this font, what kind of low-level font features are enabled for this particular font. And this is information that you can get access to by calling metadata.blob. You need to be a font expert, which is why I've skipped it here. So if you work in the design space, if you work with, I don't know, lower level font features, some of these may be known to you, but the local font access API gives you information to this. So if you want to, you can get access to the low level font details as well. But in this, to learn more about this, I've written an article about the API where you can read all the details, especially when it comes to the lower level font details. If you're interested, this is the QR code that you can scan to then get to the article directly. So this is a bleeding edge browser API. So one way to use it right now is to flip a flag in Chrome. If you go to Chrome://flags, you can search for font access, and you will find this particular flag that you can then flip to enable. You restart your browser, and then you can use it. The good news is this we launched it in a so-called origin trial. An origin trial is something where you can opt in your website and say, I want to take part in this origin trial, and I want to use this particular browser API and make it available to my users. So if you are example.com, you can opt in your page, your domain example.com at this origin trial register page. You get back a token, you put this token on every page that wants to use this API on example.com, and then every user on the world that uses the Chrome browser and is a user of your website, talking about the origin trial that you can sign up for, and that allows your users then to access the API as if they had the flag toggled locally. I've actually built a demo that uses this API. If you scan the QR code, you can test it live in your Chrome browser. This is what it looks like. The first thing that it does when you click the font selector is that it launches the permission prompt. And let's zoom in so you can see here what it tells you right now. Right now it spells, use the fonts installed on your computer so you can create advanced typography. So we are still working out the details of this, but this is what it looks like right now. If you allow this API, then the person can access all the browser can access all your locally installed fonts. So this is the permission prompt, and then you will get the font selector here populated. So all the fonts are installed and that are installed will be listed in your font picker. And you can see also wingdings. So you can just select any font that you want and render it on the screen. So the local font access API, as I said, is something that is being worked on in the context of the WICG, and where some of the issues are being worked out on GitHub. So if there's anything at any point where you see the API is doing something that you would not expect, you can report an issue on GitHub, a spec issue on GitHub. If you click through to the GitHub link on the spec, this is the page where you land. It's a classic GitHub repository where you can see the list of all the issues, and you can read and comment on the existing issues, or also just submit a new issue if there's something that you want the API to do that it doesn't do right now, or if you are not happy with the current behavior, you can fix it and hope for someone to pick up and suggest new things. The spec is one thing, but then sometimes there's also a problem just with how Chrome has implemented this API. It may not be the same all the time. So sometimes maybe there's just a bug in the implementation where the spec says the API should do X, but maybe the Chrome implementation does Y. And this is where Chrome Platform Status comes into play. It's a website that allows you to search for all the new APIs. One of them, of course, the local font access API. And when you click through to this particular section of the Chrome Platform Status page, you can then see the details about Chrome's implementation. And one of the things you can see there is a tracking bug where you can click through and you're brought then to the Chrome backtracker where you can see exactly the details of the implementation work for the local font access API in this case. So it's a classic Chromium bug. So you have all the details, you have all the links, you have all the people. So if you are interested in what Chrome engineers in detail work on this, you can directly see it here. So that's pretty powerful because you can get direct access to Chrome engineers who work on a particular feature that you are interested in. And it's all work happening in the public. So any kind of thing that you suggest here, someone from the Chrome team will read it. The local font access API is only one of many, many APIs that we work on in the context of Project Fugu. And we have a list of all the APIs that we work on. You can access it by going to goo.gle/fugu-api-tracker. And it's a Google sheet with a list of all the APIs that we have shipped already. If you scroll down a bit, all the APIs that are currently in origin trial. If we scroll down even further, all the APIs that are in dev trial. So dev trial is the thing where you need to toggle a flag in order to use it. And then finally, at the end of the list, an API of the things that we, a list of the APIs that we want to work on in the future, but haven't started on working yet. So there's a couple of APIs also that are under consideration. So it's APIs where we think about, is this something we should be working on? It's a very long document, and you can see it's a very long task list for the project members to work on in the future. This might be a little overwhelming for most people. Not everyone needs to know every single detail of our plans, which is why we have a landing page that is dedicated to just showing you all the things that you can play with right now. It's on our page web.dev, and it contains all the APIs that we currently have implementations for. You can find it by scanning this QR code. And if any of the APIs trigger your interest, you will probably find an article there that describes the API in detail. So now I want to get a little more concrete and talk about these APIs. One recent API that I've worked on is the multi-screen window placement API. So let me show you what it is. Present window.screen API gives you access to details of the local screen. I have a MacBook Air 13-inch. It's a small machine that I got for traveling. None of the traveling happened because thank you, COVID. But yeah, now I'm stuck with it at home. I'm using a MacBook Air 13-inch as my main machine. And if you look at this, you can see available height, available left, available top, la 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 la. So you can see a couple of information about my local screen. But the thing is, my working at home setup actually looks like this. And it's kind of funny to look at this on this photo because it actually looks like this today. If you look at my home working setup today, it's actually looking like that. So the thing is, I don't have just one screen, I have two screens. My second screen is an iPad Pro that I've connected to my main laptop with the macOS sidecar feature that allows me to extend my screen to a second screen. So it is as if I have two screens connected to my machine. But the old window.screen API doesn't give me any information about that. This is where the new API comes in. The new API gives me information about all the screens that are connected to my machine. Again, it's a very powerful API. I don't want all the website on this planet to know about my Windows setup, but only maybe a couple of pages that I engage with on a regular basis. So this is again the permissions API here, navigator.permissions.query, and I have a name for this API, which is called window placement. And again, as before, I continue only if the permission is granted. And now I can call window.getScreens, which is an asynchronous API call. And this then gives me access to all the information, to all the screens of all the, to all the information of all the screens that are connected to my laptop right now. So you can see the screen 1 is the same screen as before, the MacBook Air screen. But then the screen number 2 that you can see in the right column is the iPad. So now I have information about how this iPad is connected, what kind of window width and color depth and whatever it supports. And with this, I can also calculate the window arrangements. I can know, is this iPad positioned right next to my main laptop? Is it above? Is it beyond? Is it on the left? Is it on the right? So I get information about my screen setup, which is very powerful because like that, I can create more powerful applications. One application that I've built is a demo application that you can access at window-placement.glitch.me. And I'm not sure if it's a very popular children's book in Russia or your part of the world, but there's this elephant called Elmer that is with colored squares on his skin. And this is why I chose this as the theme of this API demo. If you click the button, you will then get an arrangement like this. So this application creates pseudo cryptocurrency charts. So the idea here is to show this is a trading desk. So I faked it, of course. It's none of this is real, but you can see here I'm staring at the screen and I'm very scared because some of the cryptocurrency that I don't own is going massively down. So why is this powerful? Because now I can arrange each chart according to my screen setup. So you can see here, this application takes into account my screen setup to then display the charts evenly distributed across my 3 connected screens that are all together forming my virtual trading desk here. And if you imagine something like, I don't know, NASDAQ, where people have massive screens, and massive screens, not just one, but several connected together, this is a very powerful concept for these kind of multi-screen, multi-window arrangements. All right, the next API that I want to talk about is the keyboard lock API. There's also an article out there, so if you were interested, go to the landing page from before. You can read up all the details. But the core idea is to capture certain keys. So one example is maybe you have a full screen application. You're running a virtual machine on a remote server that is streamed to your browser tab. And you go into this browser tab and you make it full screen. And then maybe in your streamed environment, you want to launch a browser that is running on your server, but that you stream locally. And of course, you don't want the local machine to use the keyboard shortcuts. So let's say you run this on a Mac. You don't want your Mac to consume something like Command Tab or Command N, which are the shortcuts for creating a new tab or creating a new window. But you want these keyboard keys to stay within the application that you're streaming. So using the keyboard lock API, you can then lock these keys. So you can say the meta left key and the meta right key in combination with tab key N and key T. So the N and the T key in any combination of Shift, Command, Control, Alt, what have you on your keyboard should just be locked and stay within the application. The article, sorry, I'm scrolling in the wrong direction. The article has more details. The demo allows you to check this API, so you can try it at home if you go to keyboard-lock.glitch.me. And if you launch the application in full screen mode and then activate the keyboard lock, you can then try pressing Command N and Command T, or Control N and Control T if you're on Windows or Linux. And you will see that you see this error message here that the keyboard lock API has captured these keys. If you disable the keyboard lock, you will be kicked out of the application and a new window or a new tab will be opened. So this is, of course, not what you want in most cases. All right. The next API that I want to talk about is the Clipboard Access API, which allows you to get low-level access to the system clipboard and also get access to binary data on the clipboard. How does it work? Let's imagine you have an image. So you have an image URL, images cat.png, and you fetch it locally and get the blob of it. So now you have a blob of the image. And now you can write this blob to the clipboard. And you do so by calling navigator.clipboard.write. And then you pass it an array of clipboard items. And the clipboard item is essentially an object with the blob's type as the key and the actual blob as the value. Now you've written this blob to the clipboard, and you can then continue and paste the image somewhere in a different application, for example. I've written a small application that allows you to test this. So you can see here, it's not very nice to look at, but it's fulfilling its purpose. The core idea here is to have a little demo painter application where you can paint on a canvas and with the File System Access API, open and write files. With the Asynchronous Clipboard API, copy and paste images. And we've seen it before with the Local Font Access API, write something in your local fonts. So what I've written here is Strasbourg HolyJS using a font that I have installed on my local machine. It's called Chalk Duster. And you can see Chalk Duster doesn't have letters for Cyrillic. So for Strasbourg, it falls back to using the system default font. So I don't know, something like Times New Roman in this case probably. But for the fonts, sorry, for the letters, where it does have letters for, so HolyJS and the little ASCII heart here, you can see that's using the chalk duster font that is installed on my machine. And you can see the font picker from before. It's a custom element that I've created that allows you to just install a local font picker easily in this application so you can use it. This application fully works. So I was talking about the clipboard API. If you click the copy button, I can then actually just paste this image into my slide deck here. So this is what I did yesterday when I created the final deck. I went to the application, wrote this little message, starts with your HolyJS, and then pasted the image right into my Google Slides slide deck here. And this is the image that you can see. And of course, just for the proof of it, it's very small, but maybe you can still see it. I can, of course, also now use Google Sans. So here I am writing Здравствуйте HolyJS in Google Sans, the Google corporate font. And you can see Google corporate font is available in Cyrillic. So you can see the Cyrillic letters finally work. It's not a very beautiful font. It's just a boring corporate font. But you can see it's using Google Sans on the web, exposed through the local font access API. If you want to test this demo, or if you just want to see more details, this is the QR code that you want to scan with all the details to all the APIs that I was talking about. So remember, the initial message was leave no one behind. Whatever you build, remember that there will be people who use browsers that won't have a particular API that you need. Maybe it's not enabled, maybe they don't have it, maybe they use a different system. So whatever you do, leave no one behind. Use progressive enhancement so that everyone on the planet can use your application, maybe not exactly as you intended in the most powerful way, but still they can use the baseline application. What does this mean? If you remember with the very beginning, with the example, maybe they can only use 24 web-safe fonts and not the 310 fonts that I may have installed on my computer, but they can still use the application, just not in the full form, but in a lower level form that still allows them to do useful things with the application. And with that, spasibo большое. Thank you very much for listening. If you're interested in the slides, they are available online, goo.gle/holyjs-fugu. I'm Tom Steiner. You can reach me at Tomayak on Twitter all the time that you want. And I think we now have time for questions in the discussion zone. Thank you very much for listening. And yeah, let's move on to the questions.
Thomas, thank you very much for your speech. It was very impressive, especially for me. I discovered new amazing KPIs. And I will ask you to, if you have some links near with you, with your demos and such, could you just put it into the chatter, I mean Telegram chatter, to all of users who are watching us from PC to just follow up and play with some demos. And yes, I have quite a lot of questions. And let's start with some related to keyboard API. Not really keyboard, I mean keyboard-based API. Do we need an user action to read from keyboard API in case we're trying to get something for mobile devices? Because in my understanding currently, we could use some kind of paste built-in functionality, for example, in iPhone, but we have to find some input to allow for paste action to be fired. But how we could work with images or such, because it's kind of binary data and create input for it for mobile devices looks scary for me. Maybe you could highlight this approach.
Yes, so that's actually a couple of questions in one. So let me start from the beginning. So the keyboard lock API specifically is an API that is only useful in a full screen context. So only if you have full screened your application, only then can you use the keyboard lock API, because else the idea is that you're not really using exclusively one application, but you have the browser window, you have some other windows, but if you have a full screen application, only then, of course, are you using one application concretely. So in this case, the keyboard lock API will only do something when you have the full screen mode activated. In general, so a lot of these APIs are very, very powerful. So as I said before, local fonts, if you know that someone has Google Sans installed, you know that they are probably a Google employee. There's a couple of more examples like that, even some unexpected things. But security and privacy is a very, very big topic for all of these APIs, which is why we iterate on the team using different methods. So first of all, before we try to launch something, we try to think any kind of possible ways. How can people abuse this? How can people do things that are maybe evil, that are maybe just creative hacks, but that may be abused into evil hacks? So we try to figure out what is the way how people can abuse this API. When we then have an idea of what can go wrong, something that we require very early on is a so-called tag review with the W3C. The tag is the technical architecture group within the W3C. It consists of elected experts who have a very deep understanding of the web. And we just present the idea and say, look, there's this idea to having a new API that does, I don't know, give access to local fonts. And the tag review requires the authors of a spec proposal to have thought about the security and privacy implications. So there's a questionnaire also that they provide that the authors need to fill out. So the tag review is a very public place where an API is essentially stripped down to the bottom, where everything gets discussed and security issues get hopefully detected, revealed, so people can then try to make the API more secure in the process of shipping, in the process of moving the API forward. So the idea there is really by working in the open and by from the beginning requiring to be open about plans, that a lot of problems get caught very early on. And there's even a lot of small things, like in the beginning I showed something about the permission prompt text. So can we still see the slides, by the way?
I believe so.
Okay, so let me just quickly go back so that you can see what I was talking about. Here, so this slide has highlighted here the details of the font access prompt. So I can tell you from internal discussions, there was a lot of back and forth. What is the right wording here? So if you tell someone, if you reveal all your fonts to this website, you might be tracked. That's of course true, but it may not be necessarily what we want here. People don't understand what this means in general. So what we try to make it here is, right now the message reads, use the fonts installed on your computer so you can create advanced typography, which is also not the best message maybe, because what if someone just wants to use it in a creative way, and they want to paint something maybe, and they just want to write but not really create typography? Like what does this even mean? Is creating typography creating a font, or is it using a font, or what is it? So there's a lot of experimentation also with an internal team called Chrome UX that presents messages like this to real users and asks them, what do you think this API can do? Or does it sound scary to you? Is this something where you would say allow, or is this something where you would say block? So there's a lot of work going on that we make sure that these APIs land in the right way. And origin trials are trials by definition. So we try something. We want to get experience with how real people interact with this API and how real people understand certain features of an API. So there's also some measurements in place where we can see, for example, how many people disallow or how many people allow certain prompts, so we can get a better understanding if maybe some of the wording needs tweaking, or maybe needs to be more scary, so that people know, okay, if I click yes, I might be in danger or something. So this was a very long response. Maybe it answered your question, maybe not.
Okay, thank you very much. I have a question related to Screen API from development side. I mean, so you mentioned we have some API like window get available screens or such, and I'm trying to get how is it looks like from the DOM side. Is it kind of new window or this is just a new DOM node? Could we just get one node from main screen and put this node into another screen, or is it's different contexts? I mean, DOM contexts. Could you highlight this one?
Let me just bring up the slide that has the details. This. So it gives you back an object that has details about both screens. What operating systems do is they kind of combine your screens together to a virtual screen. So when you move the mouse from one screen to the other, it's just appearing as if it were one screen. So here we still have the knowledge about that in the end it's two screens, but what this allows you to do is to create one huge virtual screen. So you can know if virtually, let's say your first screen is 1,000 pixels wide, the second screen is 2,000 pixels wide. If you place something 1,050 pixels, you know it will be on the second screen, just because your virtual arrangement is like this. It doesn't have anything to do with the DOM. It's really just a virtual representation of how your screens are arranged. So that's the core idea here. And because you have an idea of how the screens are positioned in the space, you can then also know are the screens arranged like this and this, or maybe next to each other. By just looking at the properties that get exposed here, you can calculate what is the current virtual screen setup.
Okay, and once we will calculate these positions, for example, let's imagine a situation, I have some video and I'm trying to just move it to another screen. I'm requesting list of available screens and I'm just getting new position for this window and I'm applying it to it, or just I need some additional method call to update its position from screen layout?
You just really directly change the position of the window. You get access to the screens, like window.getScreens, and then you know the window arrangement. And then with the new window, you can say window move to, and then the new X and Y. And as I said, they are logically just as your virtual big environment is. So you can move a window to whatever, as I said before, 1050 pixels to the right, and you know this window is now, or this video, whatever, is now on the second screen.
Oh, cool. Thank you.
By the way, you also get information.
Yeah.
You also get information about what kind of screens they are. So if you look at the details here, you can see it has internal true. So you know this is an internal screen that is built into the device, and internal false means it's an externally attached screen. You also know things like, does it support touch? Because nowadays a lot of external displays also support touch, or even if you have a special, like for example, Pixelbook, your main screen will have touch support. So there's information like this that is available. If you compare to the old API also did give you information about touch. It didn't give you information about certain other things. Like, for example, if we go back here, you can see something that is not available is this entire thing of what kind of ID does the screen have? So the ID is an idea for allowing to rearrange a screen layout. So let's say you use your laptop on the road, so just the laptop alone, and you use your laptop in your office. In your office, you have a two-screen window arrangement. At when you are on the road, when you use the laptop alone, you have just a one-screen arrangement. By exposing the IDs, you can then store this locally in your database and say, if my application is running with two screens, I can rearrange the windows exactly as they were before. So a lot of developers do this. They have a very specific console setup, for example, so they know exactly my VI is top left, and then my Emacs is top right, and then my whatever browser is bottom spanned across the window, and so on. So you can restore all these settings by using the IDs that get exposed here.
Oh, very good. Thank you. And as I understand, currently for Windows and some kind of MacBooks and tablets integration, we could connect some kind of Wi-Fi screen. I mean, we could connect our TV as an additional screen and such. And it has some downsides. It's latency and frame rate. Is a way to get it using built-in APIs, or we have to measure it somehow manually?
Oh, so the latency that you introduced by this, I don't think this is exposed right now. I'm not sure because in the end, this is depends on the technology. So you can see my screen behind here. This is what is it? Samsung, but it's using internally AirPlay from Apple as a protocol. But it also has something called Wi-Fi Direct. So I think it depends on the concrete technology that you use, how this gets exposed. There's another API that allows you to use the Chromecast protocol to cast things on different screens. I don't think any of these APIs currently have any kind of information about latency. But this would be a good spec issue. So you could say, I'm a developer, and for me, it's critical to know how much delay or how much latency is being introduced by the secondary screen or a third screen or whatever. So you could open a spec issue and say, could we make latency available? And like that, the Chrome engineering team would then look at it and say, how feasible is it? Like one of the things they always ask is, do we even have this information at the operating system level? So if macOS, for example, has no idea how much latency is introduced, there's of course no way that a browser could expose this because the operating system doesn't have it. Or maybe there would be some sort of workaround by measuring it manually or something. So emulating in software what the hardware doesn't give you or something. So a spec issue would then be a great way to get all these constraints and discussions going with the different engineers, because the engineers have insights into how all the operating systems that they need to support expose certain features. So this is a very good example for a spec issue that you could file.
Oh, maybe I will try to open an issue. Thank you. I have a question related to keyboard lock feature, and what happens if we enabling keyboard lock for some screen maybe, and after it user just plug it off? Is it some promise-like API which will fail, or we have some own plug off callback or such?
What does the user do? I didn't understand this part. The user blocks
I mean,
off, or what did you say?
plug it off some display. I just power off some maybe monitor or virus
Oh, I see. If
display
the
and
user
such.
unplugs, if the user unplugs
Yes.
the screen. Okay, in this case, the screen, so the new window placement API makes available an event listener. So you get information about the rearrangement of the screens. By the way, in my demo, like the one here with the multi-screen windows, if you unplug it, you can directly see how the screen reacts, how the screen rearranges the different chart windows. The question was in context with the keyboard lock. In this case, you would have to, so as I said before, the keyboard lock only is effective in full screen mode. In a multi-screen window environment, you can only, as far as I can tell, make one screen full screen. So there's not a way to make something like a virtual big full screen. I don't think this is possible yet, probably because of different resolutions that are underlying. So in this case, if you unplug, you would leave the full screen mode, and then you would also lose the keyboard lock.
Okay, thank you. Yeah, it's interesting. I have a question related to Web Fonts new API, and as I'm a Windows user, as I know, there's a few extensions for fonts in Windows. I mean, different types of fonts, kind of it. Is Chrome supporting all the types from the system, or it's we need to have some specific type of fonts to get it available using this API?
So I'm not a font expert. One of the font experts in Google is a person based in Finland who is called Dominic Rötches. you can ask this question to him, but my answer is so far, you can get access to the fonts per se. You can get a list of the fonts. You may not necessarily get access to all details of the fonts. So there's different types of fonts, like TrueType, like I don't know, OpenType. There's SVG fonts, for example. So there's a couple of fonts that are available in different formats. You may not necessarily get access to all of those details that you're interested in. But for the concrete details, I have to point you to Dominic. If you're interested, like Dominic Rötches, Google Finland, you will probably find him if you search for him.
Yeah, it's quite near with St. Petersburg, but currently I believe borders is closed, but it's kind of a 3-hour trip using Allegro train from St. Petersburg. Yeah, thank you for the answer. And I have a more general question related to feature prioritization inside the Chrome team. You mentioned you have a spreadsheet with all features, statuses, and such, and maybe you could highlight how these features are prioritized, and is it a team decision which features to take for some kind of sprint, or I doesn't know how is it working in Google, but what is the process? Could you describe it, please?
Mm-hmm. So Google works with a lot of partners. So we have relationships with big names in industries, smaller names in industries. So essentially, all these APIs are partner-driven. So if we work with a partner who is active in the, I don't know, graphics editing space, they might ask us for an API that does certain things, like, for example, local fonts. So we work with them, try to get their understanding, what is it, what they want. Microsoft, Intel, they work probably in a relatively similar way. So Microsoft, of course, also has partnerships that they maintain with the big industry partners and the small industry partners. Intel, by the way, and this is an interesting question, why is even Intel part of this? Intel, as the chip manufacturer, has done some analysis, and they have found out that more than 50% of CPU cycles on their Intel chips are spent on a browser, which is why they want to make sure that the browsers are using Intel chips as efficiently and as well as possible. So this is why Intel is part of this. I'm not sure about like how they would choose what to work on, if they have partnerships or not. Probably they have, but yeah, essentially our prioritization is partnerships driven. But then of course we have a team that I'm part of, which is developer relations. So we also work with developers, and we try to get developers' opinions just the same on the table as some big or small industry partners. So if we do a conference talk like this, and you talk about, I don't know, latency was a good concrete example. This is something that I can take back to the team. And I talk to a lot of developers, not so much in person, of course, anymore, but like on Twitter, on social networks, just by email. So I try to get a feeling of what developers want as much as possible as I can, and then bring this back to the engineering teams and say, recently I heard a lot of demand for a certain particular feature. So a concrete example is for the file system access API, right now when you save a file, you can't suggest a file name. So typically what people want is they want to suggest, I don't know, unknown Photoshop file, for example. But nowadays they can't. So all files end up being by default named untitled or unnamed or something. So this is a small feature, but something that I hear a lot of people comment about, that I see a lot of people work on GitHub issues in. So this is then something that I bring back to the engineering team and tell them, look, developers asked for this and that. Can we make this a priority? And good news for this particular feature, by the way, it's being made a priority. So soon you will be able to suggest file names using the file system access API.
Oh, thank you for the answer. And you mentioned possible security issues related to all these APIs, especially fingerprinting. And as I understand, in general, main approach about fingerprinting is adding some kind of randomization for example, we have to wait some time for some static APIs or such. But maybe you could highlight more some general approaches how to deal with fingerprinting.
Yeah, fingerprinting is something that comes up a lot. That is something that comes up in the technical in the tag reviews, in the tag review questionnaires. It comes up initially when we create this feature spec and we write documentation about how a certain API should look like. There's a couple of ways around it. So one of them is just making sure that the API can only be used when the person has granted access to it. So permission prompts. Another way is randomization. So something like Canvas fingerprinting, where, for example, the Brave browser has made their process public of how they randomize a little bit some of the small details that typically would be unique to one browser, that they randomize the Canvas painting somewhat so that common Canvas fingerprinting just doesn't work anymore. Another approach is just lying. So one idea is if you ask the user to reveal all their local fonts, for example, an implementation could choose to just, instead of I had 310 fonts on my computer, you could have an intermediate step where the user can again select only whatever 5 fonts, and then it could lie back and say, as an API, the user has locally installed exactly one font, and maybe it's the one font that you have granted access to. So there's a lot of free space for implementers, for browser vendors, to make certain specs implemented, like fully spec conformly and implemented, but then have some additional security steps by lying and saying, instead of the actually 310 fonts, you only reveal one of them. A good example that you can see today of Apple doing this, Apple has implemented asynchronous clipboard API so that you can copy and paste images. But what they do is they have an additional user step. So instead of just saying paste programmatically, they have this additional UI step that gets created. So you have to manually click again on a paste button that they generate. This is not part of the spec, and they still make their implementation spec conform. But by making this additional step, they really make sure that you make an educated choice about pasting something, so that you're not surprised by something secretly reading out your clipboard, but that you have to press a button each time. So this is a couple of ways how we can get fingerprinting and how we can get access to a powerful feature into control. And then of course, just as I said before,
yeah.
As I said before, just tweaking the text of the permission prompts, for example. So a lot of small details that you might not think take a lot of work actually do take a lot of work, because there's a lot of user studies as well that are involved, where you make sure that things are really correct in place.
Thank you. I think our stream time is gone, and I would like to ask our colleagues to join discussion zone in Zoom, and I think we will join it in a few seconds or such. I'm passing mic to Mikhail.
Yeah. Thomas, thank you for your talk and answers. Alexander, thank you for your questions. Let's go to the discussion zone. Have a good discussion. Bye-bye. Nice to see you.
Bye-bye.
All right. See you soon in the discussion zone.